Assuming you put it where the Sun is, it would relax to the circle of Jupiter, a beast absolutely temperamental and going to detonate. They are among the most conspicuous effects of radio energy in the whole universe, conveying more energy than a billion suns. Betelgeuse, or Bug Guju as some call it, is a red giant star. On the off chance that you put it where the Sun is, it would extend to the orbit of Jupiter. It is colossal, totally erratic, and also going to explode. When we consider stars, we undoubtedly imagine little, gleaming objects in the night sky. Essentially, this is how we see them from here on Earth. However, stars are something else entirely. Betelgeuse, perhaps one of the most remarkable stars, is much larger than our Sun. For a long time, this star has puzzled researchers. However, recently, something more disturbing has been happening with Betelgeuse, causing scientists and other experts to grow extraordinarily concerned. Join us as we explore the startling news about Betelgeuse, its potential destruction as predicted by the James Webb Space Telescope, and what this new discovery means for our universe and our lives on Earth. As explained by physicist Michio Kaku, Betelgeuse is a tremendous wonder, a giant star that has intrigued astronomers for years. A Greek astronomer named Antonius was the first to document it. This star is so massive that it can be seen from Earth in the night sky, especially during winter. If you're into astronomy, you've probably seen or heard of this star. The reddish-orange star marks the upper left shoulder of the Orion constellation. Betelgeuse is ancient and one of the brightest stars in the night sky. However, one peculiar thing about its brightness is that it doesn't remain constant. Rather, it fluctuates. This fluctuation is one of Betelgeuse's unique properties, but it's not the only one. Let's explore some of its fascinating characteristics. Most of the stars you see in the night sky are incredibly far from Earth. The closest star, Proxima Centauri, is 4.2 light-years away. If you're unsure what light-years means in terms of distance, picture traveling at the speed of light for an entire year. Light travels at 186,000 miles per second, so the distance it covers in a year is about 6 trillion miles. When we say the closest star is 4.2 light-years away, we mean it's over 25 trillion miles from Earth. Now, consider this. Some stars are much farther away, and Betelgeuse is one of them. Betelgeuse is located roughly 600 light-years from Earth. Even if you could somehow travel at the speed of light, it would still take 600 years to reach Betelgeuse. We cannot travel that fast, and not even our fastest space rockets can come close to that speed. Yet, despite its distance, Betelgeuse shines brightly in our sky. If you're wondering how Betelgeuse can be so bright despite being so far away, it's due to its remarkable properties, such as its size and luminosity. Betelgeuse is many times larger than our Sun. Its radius is estimated to be hundreds of times greater than the Sun's, making it appear as a disk in space when observed with modern telescopes, unlike other stars, which appear as mere points of light. When it comes to mass, Betelgeuse weighs about 12 to 19 solar masses. A solar mass is the standard unit of mass used by astronomers, equivalent to about 2 times 10 superscript 3 kilograms. Scientists cannot determine the exact mass of Betelgeuse because it doesn't have planetary bodies orbiting it to provide a basis for comparison. Clearly, we also can't measure it directly from Earth. This makes Betelgeuse at least several times heavier than our Sun. Its luminosity ranges from magnitude +0.0 to +1.6. To put it in simpler terms, Betelgeuse is thousands of times brighter than our Sun, which is why it's nicknamed a red giant. However, Betelgeuse's brightness doesn't remain constant. It fluctuates. This variability is due to its pulsations. In other words, Betelgeuse expands and contracts. When it expands, it gets brighter. When it contracts, it dims. This cycle can last anywhere from 10 to 100 days or even longer. Another interesting property of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field here is much stronger than on a typical stellar surface. Unfortunately, these strong magnetic spots disrupt the flow of hot gas to the star's outer surface, causing the star to cool in those regions. Betelgeuse has far more magnetic spots than our Sun, which explains why it is cooler despite its immense size and brightness. The Sun also has dark magnetic spots, but those on Betelgeuse are much larger and more numerous. To give you an idea, some spots on Betelgeuse can be twice as large as Earth. Betelgeuse also boasts a magnetic field that is significantly stronger than the Sun's. This field causes the gases on its outer layer to appear in arcs or loops when observed through a telescope. Betelgeuse has a surface temperature of about 3,500 K, which is much cooler than the Sun's surface temperature of 5,778 K. This low temperature contributes to its reddish color and lower energy output compared to hotter stars. Interestingly, Betelgeuse wasn't always red. It was yellowish about 10 million years ago, similar to our Sun. Over time, its color gradually changed to orange-red and, eventually, to the deep red we see today. This color change has led scientists to believe that Betelgeuse is evolving. It produces about 100,000 times more energy than the Sun. If it were closer to Earth, it would rival the Sun's brightness and possibly outshine it. The fact that Betelgeuse, 600 light-years away, can still be seen with the naked eye is remarkable. Our Sun is only 8.3 light-minutes away, which is why it appears so bright. If Betelgeuse were closer, we'd also see it during the daytime. However, if Betelgeuse were to replace the Sun, its immense size would engulf the orbits of Earth and the inner planets. Additionally, its radiation output would far exceed that of the Sun. Betelgeuse is truly a giant star in the Orion constellation, approximately 600 light-years from Earth. Its enormous size is one of its most striking features. If placed at the center of our solar system, it would extend beyond the orbit of Jupiter. This incredible size allows Betelgeuse to appear as a disk rather than a point of light when viewed through modern telescopes. Rather than being a place of light when seen through strong telescopes, as opposed to most different stars, regardless of its monstrous size, Betelgeuse isn't the most gigantic star. Its mass reaches from around 12 to multiple times that of the Sun. This variety in mass evaluations is due to the difficulties in unequivocally estimating the mass of stars that lack companion stars or different objects to provide gravitational reference points. Even at its lower estimated mass, Betelgeuse remains an immense celestial body. The brightness of Betelgeuse is another key characteristic. It fluctuates consistently over time, with its brightness ranging from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can be up to 100,000 times more luminous than our Sun. This change is attributed to its pulsations, irregular expansions and contractions caused by internal cycles within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These pulsations can last for years, contributing to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a massive star, measuring around 3,500 Kelvin. This gives it a distinct red color, typical of red giant stars nearing the end of their life cycles. Like other red giants, Betelgeuse is in the late stages of stellar evolution. It has depleted the hydrogen fuel in its core and has begun fusing heavier elements. This fusion process produces energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena. It displays dark magnetic spots on its surface where the magnetic field is stronger than the surrounding regions. These spots prevent the convection of heat, leading to cooler regions on the surface. Despite these cooler spots, Betelgeuse remains a massive and energetic star, but it will eventually meet its end in a spectacular supernova. Betelgeuse is a colossal star nearing the end of its life, and its potential fate will be dramatic. When it runs out of fuel, it will undergo an extreme course of fusion, producing heavier elements like helium and carbon. This will cause the star to expand to potentially even greater sizes, making it one of the largest stars in the night sky before it dies in a massive explosion. A supernova is a devastating event marking the death of a massive star. The impact of a supernova is strong enough to temporarily outshine an entire galaxy. This phenomenon could send shockwaves through space, and it's possible Betelgeuse will end its life within just a couple million years, a cosmic blink of an eye, considering the millions of years it took for Betelgeuse to become the star we observe today. The possibility of Betelgeuse becoming a supernova has fascinated astronomers for decades. Recent research, particularly from the James Webb Space Telescope, has accelerated understanding of this process, revealing new data about the star's behavior. Although Betelgeuse is a red giant, its future as a supernova seems almost inevitable, and the repercussions of that event will influence the surrounding space and potentially our solar system in ways we cannot yet fully predict. Betelgeuse, also known as Alpha Orionis, belongs to the class of stars known as red supergiants. These stars represent the final stage of stellar evolution for massive stars that have exhausted their nuclear fuel and are preparing for a dramatic end. Unlike smaller stars like our Sun, which will eventually shed their outer layers and become white dwarfs, red supergiants like Betelgeuse have a different fate. They will explode in a supernova, an event so energetic it can outshine an entire galaxy for a brief time. The evolutionary path of a star like Betelgeuse begins when it forms from a cloud of gas and dust over millions of years. The star undergoes nuclear fusion in its core, converting hydrogen into helium and releasing tremendous amounts of energy. As the hydrogen in its core is depleted, the core contracts and the outer layers expand, leading to the star's transformation into a red giant, or in the case of Betelgeuse, a supergiant. In this stage, the star begins to burn heavier elements such as helium, carbon, and oxygen in its core. The fusion of these elements produces more energy, causing the star to expand even further and cool, giving it its characteristic red color. Betelgeuse's sheer size and mass make it one of the most well-studied stars in the night sky. It is a variable star, meaning its brightness changes over time. These fluctuations are caused by its pulsations, where the star's outer layers expand and contract. As Betelgeuse pulsates, it causes periodic dimming and brightening, making it one of the most fascinating stars to observe. These pulsations are believed to be linked to the star's instability, a common trait of stars nearing the end of their life cycles. Scientists have been able to track these changes in brightness, helping them learn more about the star's internal processes and its potential fate. Despite its size and brightness, Betelgeuse isn't the largest star in the universe. Other stars, such as Uy Scuti, are even more massive. However, Betelgeuse's location and variability make it a particularly valuable subject of study. Its relatively close distance to Earth, around 600 light-years, allows astronomers to study it more closely than many other stars. Observations from various space telescopes, including the Hubble Space Telescope and the recently launched James Webb Space Telescope, have provided insights into Betelgeuse's structure, magnetic fields, and the ways it is shedding material into space. One of the most exciting discoveries made by scientists recently is the possibility that Betelgeuse is closer to the end of its life than previously thought. While it was once believed that the star still had tens of thousands of years before going supernova, later data suggests it might be only millennia away from this catastrophic event. This timeline is much shorter than previously expected, captivating astronomers and sparking further studies into its behavior. The most recent observations have shown that Betelgeuse's outer layers are beginning to eject large amounts of gas and dust, a process known as mass loss. This mass loss is typical of stars nearing the end of their lives, as they shed material no longer needed for fusion. This process is not only significant for understanding Betelgeuse's future but also for the broader understanding of how stars evolve and die. When Betelgeuse eventually explodes in a supernova, it will release an enormous amount of energy along with heavy elements like iron, nickel, and calcium. These elements will spread throughout the surrounding space, enriching the interstellar medium and providing the raw materials for the formation of new stars, planets, and possibly even life. In this sense, the death of Betelgeuse will not be an end but a beginning for future generations of stars and planets.